Hey everyone, welcome to this demo tutorial on how to connect to Mongo database from your web application. Now for this, you would need to use MongoDB. So Mongo is a NoSQL cloud-based database which you can use for your projects. Now Mongo does have a local version or a certain version which can be deployed on the premises of an organization. But however, for your projects, you can actually go with the online version of Mongo, which is available from this particular link. Now, once you visit this particular link, you would have to first sign in and create a new account in Mongo database. So once you sign in, you get an option to log in or sign up your account. In my case, I have signed in with my Google account, and that's why I was able to get into the particular portal which is customized for me. Now, in your case, you can also log in using GitHub or even using your Google accounts, whichever is easy. And once you log in, you will land into this particular portal. Now, in this portal, you can create different projects. You can also have multiple databases under one project and various other services which are mentioned here. So Mongo also has a commercial version which requires a subscription and a corresponding subscription fee to access all the different features which are available within MongoDB. But for your projects, you can go with the free version, and the free version should be sufficient for the web application that you will be developing. Now, first, you would need to create a new project. So when you log in for the very first time, it can ask you to create a project in the very first login itself. If the wizard doesn't ask you to create a particular project, you can always create a new project from here. So you can click this and click a new project. Now, in my case, I have this project already created. So once the project is created, I would need to create a database. So for that, you can go to the database option and you can actually create a new database from here. However, in my case, I have already created a database which consists of some amount of data. Now, these charts kind of show you when your data was last accessed and gives you some idea about the data size and the consumption of the data depending upon the storage that is provided to you. So with the free version, we can get up to 512 MB of storage, and currently my data is 134 MB in size, and that's why I can proceed with it. If you are creating a new database, you would have to first create a new cluster. Cluster is nothing but the server using which you can store and access your data. Now, there are different options like serverless, dedicated, and shared. Of course, the dedicated and the serverless comes up with some cost. So we will go with the shared version. Now, inside the shared version also, there are different options. So this Mongo database internally uses different cloud providers, and it has good integration with various cloud platforms like AWS, Google Cloud, or Microsoft Azure. So when we are creating a new cluster, which is basically a server, we would also have to select a region. It is recommended that we should select a region which is closest to our current location. If we are based out of Belgium, we would need to select a location like maybe Paris or even Frankfurt so that we get the best performance while accessing the cloud-based databases. So once we have selected that, we can then select the cluster tier. Now this cluster tier basically has different options. Now, since we are going with the free version, we just have to go with the sandbox version. If we want higher storage or higher, let's say, computational capacity, we would need to go with the paid version, which are mentioned here. Similarly, we can turn on a different backup option. For this project, I have not turned any backup option. And even for your project, it might not be required. And these are some of the cluster details. I can assign a cluster name here and give necessary tags if needed. And once done, I would have to click on create cluster. Now each project with the free version can have only one free cluster. So since I already have a cluster which is created under the project and it's under the free tier, that's why I would not be able to kind of create another new cluster, and that's why I am able to see this particular message which prevents me from creating a new cluster. Similarly, in your case, if you already have a cluster, then you will not be able to create another cluster. But for one project, one cluster should be fine. And that's why whenever you create the project for the very first time, you can create one free cluster for your usage. So once your cluster is created, it would come over here. Now this is the cluster that I had created. So I will first go into it. So when you click this cluster, you can see different properties, different configuration of this cluster. Now, the thing that we mostly need to focus on is the data that we store. So since Mongo database is a NoSQL or a NoSQL database, it kind of stores data as certain collection of files. It's like a collection of JSON files which holds the data. For that, we would need to go to the collections option. So when we create a new database, it basically creates a collection of different documents. Okay, so this is an example of a database that I have in Mongo, and this database has 6 different collections, and each collection has some set of documents. So each item that we see here, these are actually called as documents for MongoDB. So one collection can have multiple documents. And one Mongo database can also have multiple collections. So this is the database name, in our case, sample mflix, which consists of so many collections. And these are the collection names. And we can also see that the number of documents or the number of entries, you can say, for each collection. We can see the overall size that it occupies, what is the average document size, the index size, and so on. Like these are additional metadata which we get when we select the database. So the main data actually resides within these collections. And this is how we can see the collection values. So if you remember, initially I mentioned that in Mongo database, it stores data as JSON files. So it's like a dictionary format which consists of some key value pairs. Okay, so these are different key value pairs which stores the data that we want. Similarly, for your project, you can actually create similar collections from certain JSON data. You can also insert your documents, which will add a new item, and you can run certain queries so you can filter and retrieve the data that you want. So to find out more about the different kind of data operations which are possible using the cloud version of MongoDB, take a look at this particular documentation. Here you can find different options for managing databases, managing collections, documents, creating or running certain aggregation pipelines, and many more. So please do take a look at the different options which are provided here, and you would get a better understanding of different type of operations which are actually possible using Mongo database. Now let's explore what you need for your projects. Mostly for your projects, you would actually need a data API. So data API in Mongo database actually exposes certain REST API calls to the typical database queries. So usually for running different queries to the Mongo database, we actually need a server. So a server-side program which can run various queries to access or to retrieve different data or even insert data into the Mongo database. However, Mongo Database Cloud comes up with different data API options already available. So we do not need to write any code to expose these REST API endpoints to access the data, and this is readily available. So we can just make calls to these different API endpoints and interact with the data in the various ways possible. So first, what we need to do is we need to go to Data API, and you would need to first enable this Data API service when you access it for the very first time. By default, it is not enabled, and you would have to explicitly enable it. So when you enable the Data API endpoint, you would actually get a URL endpoint which looks like this. This should be the name of the application that you have used. And typically, this is very specific to the client application. For your application, you might have a different name here. Otherwise, the API URL depends on the server location and the various specification that was initially taken. Now, there are other settings which you can explore. For example, in order to access the data API, you would actually need an API key. So for the very first time, you might not have an API key created. So for that, you would need to create a new API key. So when you click here, you just have to give a name of your API key and generate the key. So once the key is generated, please make sure to copy the specific key string because that will be used when we make these data API calls. Once the data API is created, you can get different information about the API calls. For example, here you can see that with my project, I was able to make 48 API requests. And you can see when the request was made and the specific details, the response time, and so on. So all these insights we can actually get from here. And in the settings, we can further configure a lot of stuff. For example, if we want the return type to be something else, we can always change from here. But for the Wisp project, I think it's fine that you go with the default settings. It's just that you would need to make sure that the data API is enabled. Another thing that you might need to do is go to the security option, then go to network access. By default, the database or the data APIs could be accessible from specific set of IPs. So what we would need to do is we would need to allow access from other IP addresses as well. So what we can do is we can either create a new IP address or in the existing one we can edit and we can just allow access for all the IP addresses. So for allowing all IP addresses to access the API endpoint, we just need to use this particular value. Next, let us understand a little bit on the theory part, especially to understand like how the overall API flow should work. Now, whenever we talk about computer applications, we have a front-end application and we have some back-end application. The front end is the one which is used by a user. So it's the user interface. So all type of user interfaces like a web interface, a mobile interface. Even in mobile, you have Android, you have iOS, or even let's say an application which is running on television, on maybe a smartwatch, and so on. So all these applications are actually the front end user interfaces, which is actually used by the user. And in the back end, there are some operations like maybe some kind of logical calculation, some kind of data query, data access. All these things are actually done at the backend part. Now, in your course, you have learned about HTML, CSS. All these are part of the front end application. And then something like JavaScript, or maybe if you have learned about PHP, Python, these are actually backend applications, as these are certain scripts which does the logic part of the application. Now, let's understand how the overall API setup works. So in the API setup, it actually works through something called as a client server model. Okay, a client server model basically means that there is a client application and there is a server application. So whenever there is a user which uses an application, then that becomes the client application. For example, our web browsers. Web browsers are example of client-side application. So a user makes a query in the web browser, and then the query should go to the main server and then provide the response. So the main query goes as a request from the client application. Now, whenever the client tries to access the server, it happens through some API endpoints. API stands for Application Programming Interface. Now, it's an interface between the client application as well as the server application. So the request goes from the client application. It is received by the server application. Now, the server side application tries to interact with the dataset, or it has the access to the database, and then tries to retrieve different information from there. Now, once the information is retrieved, it gives a response. The response can be in the format of maybe HTML or JSON or XML file. And that response goes to the client. The client application then displays the result to the user. So this is how a client server model actually works for web information systems. Now, when we talk about REST APIs, REST APIs have different type of requests and gives you response in a certain format. There could be something like GET request, maybe POST request, PUT request, or even DELETE request. And the responses can be either in JSON format or HTML format or XML format. These are like the typical formats in which the responses are given. Now, depending upon the request, only if the request is successful, then it will give you the responses. But if the request is not successful, it will give you certain error messages or error code. Okay. However, since we are accessing some crucial information using APIs or REST APIs, in most industrial web information system, there are additional security protocols which are established. Let's understand the security protocols now. Okay, so to understand the security protocols, we would need to understand a two-step process that happens. So for Mongo, when you access the data API, you actually need a data API key. The data API key allows you to generate something called as a bearer access token. Okay, so the API key allows you to create a new passcode. It's like a one-time passcode which is given back to the client device. It's very similar how we authenticate to different like platforms which has a two-step authentication process. So it's like whenever we try to log into a certain portal, maybe something similar to, let's say, KU Locket, where you can give your initial username and password, but then you get some kind of a one-time passcode or an additional notification which is sent to an application from where you have to explicitly press approve or maybe scan a QR code to pass the second stage of entry. So something similar is actually done for web information system, where a two-step authentication process is established. Now, the two-step authentication process first involves creating an API key, and then from the client device, the API key is sent to the API application, mostly the server-side application. And using this API key, a bearer access token is generated. Now, this generated token is sent back to the client. So this bearer access token acts like a passcode. So whenever the client wants to make a REST API call, it has to provide the bearer access token. It's like sending the passcode, and using the passcode, the server-side application actually authenticates if this is a validated client user or not. So for making any REST API call, the client application should provide a bearer access token in the request body itself. Now, once this request hits the server-side program, then it will first validate the user and then provide the final response to the API request. So similarly, in Mongo database, if you need to use your web application to connect and query some kind of data from MongoDB using the data API options, first you would need to create a API key. So using this API key from the client side device, you would need to first generate a bearer access token. Now, this bearer access token would have to be used for every REST API call. Now, this token expires after a certain period of time. So whenever the token is expired, then the API call will be failed. You will not get a successful response from the API call. So that's why it's a good practice that whenever we make an API call, we first generate a new token. And once we get the response to the token, then only we pass it along with the main REST API call body to get the final response of the API. This is how a two-step authentication process works in most industrial web information systems. To know more about the Atlas Data API or interacting with the Mongo database, I strongly recommend all of you to check their documentation. The documentation is well maintained and it consists of a lot of information which could be essential for you to understand the entire process. Especially, I would recommend all of you to take a look at the Authenticate Data API process, where it talks about the various bearer authentication, the different ways by which the bearer token can be generated, and then how it can be passed to the API request to get the responses. There are other alternative authentication ways as well. However, the bearer access token is considered to be the most secure approach, and it's not a secured approach to pass the API key or even the user credentials directly as a part of the API request, because this will kind of expose the API request to certain hackers who can hack into the system and get the authenticated, or let's say the credentials, and it kind of exposes the system to such malicious usage. You can additionally take a look at the data API examples to understand the different API calls. For example, if you want to retrieve a single document, you would need to make an API request in a certain format. Similarly, if you want to make multiple documents call, and you would need the API endpoint to be in a certain format. For inserting a single document, you have a different URL or different endpoint. For inserting multiple documents, you again have different URLs or endpoints to be used. I strongly recommend all of you to go through this list, especially the URL or the endpoint which is used for interacting with the database in various ways would be important. Other than that, for using the APIs, you would need the name of the data source, the name of the database, and the collection name. Okay. Now we will see how to use this using your web application and then interact with the Mongo database and query information from the Mongo database and display in the web application, especially in the HTML part. So let's move on to that. So this is the simple example application that we will be creating. Since our database, which we saw in the Mongo collection, it consists of different movie names and movie details. So we will create a simple website to actually search for a movie based on certain keywords from the database and display the same as multiple cards using an HTML application. First, we would need to enter a movie name. Maybe let's say we want to search for Harry Potter related movies. So once we enter the detail here, we can click search, and then it will fetch all this information from the database and display it here. Okay, so this is the basic website that we will be creating to query data from a Mongo database and display in the HTML part of our web application. So let's see how to create that. So for creating the application, first we need to go to WebStorm. In the WebStorm, you can create a new project, and this project will actually have three different files. It will have an HTML file, which we can call it as index.html. It will have a JavaScript file, which we can call it as script.javascript or JS, and then a CSS file, which we can name it as styles.css. The HTML part is very simple because it's a very simple application that we have seen. So it will have the header part. In the header part, you would have to make sure that you load the CSS files. So you can just link the styles.css in the header file. You can assign a particular title. Here we have given the name of sample API data. And then in the main body, we have a form entry. A form entry basically takes input from the users, and when there is a button which is pressed, then it will create a new event. So event is like an action which is happening in HTML that can be captured using JavaScript. So that's why we have a label entry. So if you remember from the website, we have the movie name written over here. So that's a label entry. And then we had an input box, which we have named it as search box. And here we can add the placeholder text if needed. And then a simple button, which will have a submit type and the type of action that we are doing. So since we are searching something, we can just keep the label as search for the button. So whenever the button is pressed, it will create a new event, and that event needs to be captured using JavaScript. So whatever information that we will be capturing or collecting from the JavaScript file by calling the API endpoint, we can display this under this container div. So we can create a new div container where the entire data will be rendered. For the CSS part, it's a very simple CSS that we have. We have given some CSS properties for the container, and next we will use a card container to specially display the content from the API in little, maybe I would say organized manner. And for that we have the different card properties and card based let's say the CSS values assigned over here. Now coming to the main part of this particular application, it's actually the script part, script.js. And don't forget to load the script inside the HTML file. It can be part of the header or it can be part of the body as well. But we would have to connect to the script using such a tag. Now, in the script part, the main logical operation of the application happens. So, for that, we can actually start from here. This is where the main part of the script is being used. We have created a constant called form, and we are using document.querySelector form. So basically, using this document class, whenever the application or the HTML file has loaded, it considers that the document is ready now and it could be used for various actions. So we are doing document.querySelector. We are kind of listening to the forms division or the forms, like that we had created from the HTML file. We have added an event listener. So if you remember, we discussed that once the particular search item has been entered and once the button has been pressed, it generates a new event. So in order to listen to the event, we would have to create a new event listener. Using this particular variable, we can do this form.add event listener. It will try to listen to the type of the event. So here the type of the event is submit, and once the event has been captured, so this is how we are able to capture the event. Once the event has been captured, then we would have to kind of retrieve the value from the event input. So there we can do event or e.prevent default, which will prevent the default state of the event. And then what we can do is we will check the specific value. So if the the value is present, so from the form search box, which is basically the input box where we can give the search term, if the value is true, that means the value has been entered by the user, then it will first print out the search value and then call this particular function. This render data is a function which will be used to display the items which are retrieved from the API call. So it will first make the API call and then it will be used to display the values. And here we are passing the search term because we need this search term to make the data API call. And once it has been rendered, then we can reset the form. Basically, it allows us to use the the search box and the search option again. And if the value is not true, then it will just ask the user to provide some required values. It will just give a console message. Okay. Now, if we go into this function, this is the main function which is making the API call first. In this particular function, we have used something called as async and await. This is typically used whenever we are making an API call using the fetch method in JavaScript. Okay, so here we will be using the fetch method, and that's why we need to assign this async and await. It will allow us to do asynchronous API calls using JavaScript. So first we are creating a container. So this container would be used to display the output that we will be receiving. Now, in order to make the API call and get the data, we have created another function called fetch data with bearer token. And this is where we pass the search term. If I go into this particular function, this is the main function which is making the API call. So first, we have passed our API key. This is the API key which we have retrieved from the data API option. And then inside try block, so that if there are some error, it could be kind of handled properly. So we would have to, or it's a better practice to keep inside a try block. Inside the try block, first we call the API to generate a bearer token, and this is the function for that. So we need the API key from the data API option from Mongo. So if I go to this service, and this is the URL using which the API token, the bearer token, can be generated. So this is the endpoint. We would have to make a post call, as I mentioned, and we are using this fetch method from JavaScript to make the post call. In the fetch method, we would have to pass the URL and mention the type of the method. This is a post call that is happening, and mention the necessary headers and the body. In the body, we actually need to pass the API key that we have created from the data API services. So if the response is not true, it will give some kind of error message. But if the response is true, it will return the access token. Okay, it will return the access token. And similarly, if there are any other error while executing this API endpoint, it will again give the necessary error messages. Now, once the access token is created, it will be captured here. It will be captured as the bearer token. And next time, whenever we are making any kind of API call to interact with the Mongo database, we would need to pass the bearer token. So next, we are making an API call to find certain object or find certain entries from the database. We would need to specify the data source, which is the name of the cluster. We would need to specify the database name. In our case, it is sample mflix. We would need to name the collection from where we would be querying the data. So here we are actually getting the data from the movies collection. And additionally, I have created a filter option so that it can filter the records to find certain movies based on the search term. So here I am applying a filter option. This regex option allows us to filter a particular record based on a certain keyword. And I want it to be case independent or case insensitive. And that's why I have given this additional term. If you do not give this term, it will only search, or it will make a search based on certain case sensitive properties. You would have to give the proper case of the search term, which is present in the title of the movie. And here we are saying that the filter property would be applied at the title of the specific record. Okay. And finally, we are sorting all the records after it is completed. Now, once this API endpoint has been called, so we will again use the fetch method to make an API call. So we are passing the URL, we are passing the body. This is the body, by the way, of the request data, and we are saying that it's a post call, and these are some of the headers. But in the headers, since we have to do the two-step authentication, once the bearer token is generated, we would need to pass this authorization header with bearer keyword, and after a space we would have to provide the token value. So the we would have to pass this bearer token in this particular format to successfully query data from the database. So once the API call has been successfully executed, the data will be fetched as a JSON. So here we will also print the response data in the console to see the output. But then this data is retrieved and returned from this particular method. Now, once the data has been returned, so it will be then captured in this particular method. So here, if you see, this is the particular function that we are calling to get the actual response data. And this response data will then need to be printed in the HTML file or through the HTML. So we are actually getting a list of different documents or different items. So we would have to retrieve some information from the list of data. So we have captured the entire list of data in this particular data variable. So then what we have to do is, for each document, which is where we would have the main information that we need, we would have to run a loop. This is how we can run a loop. So for every item, we will get the typical information that we need. So we need, in the first term, we actually need to create a card like this. So we have to create a new card using this document.create element. It will create a new div, and then it will add this new element over here. Okay. So then we are creating a new H2 element, which is the header, and we are assigning the title of the movie in the header of the card. So we are creating the new card where in the header the title of the movie will go. Okay, so we are doing item.title, which means from from the list of different items that we have. Every item, it will capture the title value and place it in this particular title.text content variable, which is nothing but the variable which is used to display the title of every movie. Similarly, we are getting the list of director names. We are pasting it over here. We are getting the item.directors, which will give the list of director names, and creating a new element in header 4 and putting the value inside that. And then we have the plot, which is like an initial plot of the movie. And then we are getting that information and putting it under a new paragraph element. Similarly, you can think about getting the thumbnail of the movie, let's say poster, from the particular JSON document, and you can also get that and display that as part of this card. Now, once the values has been retrieved, once these HTML paragraph heading, and the various div elements has been created, we would need to append them as a child. So this is how we can append. We are appending the title to the card. We are appending, let's say, the information about the directors to the card. We are appending the information about the plot to the card. And finally, we are appending all the card to the main container element. So once this is done, all the information will be displayed under this main container element that we have here. Okay. Finally, this is how our simple application looks like. We have the title of the particular application, sample API data. We have the label inside the form. We have the search box and the search button. Additionally, we can open the inspect element and inspect different parts of, let's say, the application. For example, here we see that this is the entire div element, and inside this we have the label, we have the input, and we have the button. Okay. Now, right now we don't have anything in the console, but let's use a name. Okay. Instead of Harry Potter, now let's maybe enter something to do with trains. So if I search using this search word train, here I see a list of different movies which has the keyword train in the title name. And since this is not sensitive to the case, so we can just search using lowercase letters and we get the same output basically. And here we see that it has returned almost 38 item. We can additionally display this also, like maybe display a message saying something like 38 items or 38 movies has been found with this particular search term. And I'll just display some of them. If I expand this object, if I expand the document, these are the set of information that we are getting. We are getting information about the number of awards that the movie has won, the cast, the main cast of the movie, the country where it was launched, the directors, the full plot, the genre, even the IMDb rating, languages, when it was last updated, then the poster. So we are also getting, by the way, the poster information. If you want to print or maybe display the poster image in the card, you can actually use this particular information and certain other details. We have only used the title, the directors, and the plot, if I'm not wrong. Yes. So we are using only these information, but otherwise, if you want, you can also explore and experiment with the other values. So here if you see, we were able to create this h2 element from the JavaScript. We have created this card element, we have created this h4 element, and even the paragraph element. So everything within the card we have dynamically created using JavaScript. Similarly, you can enter any other movie, maybe let's say on flowers, and then it will retrieve all the names of movies which has the word flowers there, or maybe something with, I don't know, maybe cars. Let's try to search for that, and yeah, it refreshed and retrieved all the values where it has the name car, or it has the word car in the movie title. So this is how we can build a simple web application which can query to Mongo database using the search terms entered by the user.